Okay, let us find out with an example how to find out this curve. There is a curve given x cube to x square y minus x square y square minus 2y cube plus xy minus y square minus 1 is equal to 0. This is the cubic curve they given. I want to find out the asymptote for this. What is the logic? As you know, as x tends to infinity, whatever this curve, the whatever the I can say that for this curve, if I say y is equal to mx plus c is an asymptote to this, let us assume that we are going to say that y is equal to mx plus c is an asymptote. As x tends to infinity, both the points of, I can say that they will going to asymptotes, they are going to satisfy this equation, these things as x tends to infinity. Therefore, we substitute y is equal to mx plus c in this equation, and we have to make the x coordinate to tends to infinity. Means if you see what happens, suppose if you directly substitute y is equal to mx plus c in this equation and solve this, you cannot x you can get three roots, they are finite. But thing I don't want that. I want to find out the root to be infinite because we want this. They will going to satisfy at x tends to infinity. Therefore, what we are doing in order to get infinite roots, we are going to, as I told you in the previous classes, if you equate the highest degree coefficient they equal to 0, the one of the root will going to become tends to infinity. Therefore, we are going to set the coefficient to 0. Therefore, first after substituting y equal to mx plus c and group the x3 x cube terms, and whatever if you set the highest degree terms equal to 0, what we can get after rearranging this one, we can this can be written like this, and if you take mq common here and one common here, you can get like this, and three roots we're going to get it. M is equal to 1, m is equal to minus 7, and minus 1 by 2. Means we are going to get three slopes. And if you again if you group the x square terms and set the coefficient equal to 0, you can get c value. Once if you find out the m and c value, that is called asymptote. But as we discuss one thing, if you take, if m is equal to 1 and c is equal to 0, you can get here. See, for what happens, m is equal to 1, c is equal to 0, m is equal to minus 1, c is equal to minus 1, m is equal to minus 1 by 2, you can get c is equal to 1 by 2. For second grouping, the set the coefficient, you can get like this c. After finding the slope, means I can say that slope and intercept, if you equate this equation in this, you can get equation y square x plus c. Means what we are doing here, we are telling that this x comma mx plus c will going to satisfy whenever x tends to infinity. Because as x tends to infinity, the coordinate of this one means coordinate will going to satisfy it. Therefore you can find the one question asks, if you substitute directly once after finding the slope, m is equal to 1 and c is equal to, for example, if you take m is equal to 1 and c is equal to y is equal to x, you can get like this. No, this is the slope. But if you directly substitute in this equation, do you satisfy this equation? No. One some minute amount will going to I can say that see x cube 2x cube. Suppose if you put y is equal to x here, x cube plus 2x cube, and this 2x cube this cancel, and this x cube, because once if you put y is equal to x, you can get becomes x cube, and now and this x square, one minus 1 is going to remain. Why? Because as we told, they will never touch, but they tend to equal. All some amount will going to. But again, if you divide both the sides, still extends to infinity, this becomes zero. I will tell you how all those things. This is the basic thing I want to tell you. With an example, I will show. See, some amount minus one will going to remain the left side because we told that exact, not we are not exactly telling that it will intersect the point. Just very we are approximating, therefore minus one is remaining in the left side. What I'm telling. Just we are going to verify it, see what happens. This is the given equation. Okay, this is the given equation of the curve. What you can say, y is equal to x, and suppose m is equal to 1 and c is equal to 0 for that matter. Now I'm going to check whether it is going to satisfy or not. Okay, see what happens. This is just we are going to convert this into y by x form. Nothing will happen if you divide both the sides by x cube. What you can get, like this we're going to get it. Now as x tends to infinity, we know that y by x is going to becomes 1 here, because y is equal to x means y by x is equal to 1 here. Now this is, if you substitute back into the equation, this is what we can say that it is going to satisfy. The left side will going to remain 1 by x cube is equal to 0. But is it minus 1 x cube is equal to 0? Means as x tends to infinity, they will going to satisfy. This is what I am telling you. As in the previous classes, minus 1 is remaining. No? That as x tends to infinity, see here I will show you. See, after substitute y is equal to x, in this equation minus 1 is remaining, but you are telling that it will not going to satisfy. But as x tends to infinity, if you divide by both the sides by x cube, see, as x tends to infinity, this condition is satisfied. Therefore, y is equal to mx plus c is going to become asymptote, because at the x at x is going to infinity. If I say y is equal to tends to infinity, the y is equal x tends to infinity, the y is equal to mx plus c becomes a slow asymptote, means the coefficient of that one uh, almost satisfy the equation as x tends to infinity. Therefore, under such condition, we are going to find out the m and c, that putting back into the equation can get like this. We know that minus 1 x cube is never exactly equal to for any finite number. This seems like a problem, but satisfied at infinity. The equation is true in the limit. As x becomes infinitely large, definitely the minus 1 x cube becomes infinitely small and approaches the 0. The gap, this confirms that the curve goes to the infinity. See, once what happens by equating, we are confirming whether verifying the asymptote is correct or not. See, that it gets closer to the line slope m is equal to 1. This minus 1 by x cube is, the gap is very small and vanishes at the limit. Now we confirm that the slope main part of is 0, picked up the right value for m, and this condition holds good. Like that we can confirm it. As what I want to say is here, I don't know the asymptote, only they given the curve. I'm going to assume that y is equal to mx plus c is an asymptote here. In the previous problem, I'm going to assume this y is equal to mx plus c. We know that if I assume this y is equal to mx plus c is an asymptote, at infinity it will going to come very close to the asymptote, means at somewhere the going to satisfy this. I can say that at infinity it is going to satisfy the equation of the, because for the point of a curve, whatever the point on line is always represented by x comma x plus c, will going to satisfy. Only thing, x should be at infinity. But in order to make infinity, if we solve it and cannot can get only finite number, but in order to get an infinite root, then only we can say that x tends to infinity. For that, we need to equate, I can say that the highest degree terms, and already told you in previous classes how this, if you highest degree term tends to 0, the root going to become infinite. there, that is the reason. Under such condition, if you find out m and c, that is sufficient, and putting back into the equation you can get like this. This is how we can get. And one more thing, we can just we know that as x tends to infinity, y is equal to y by x is equal to m. We know that identity. By that identity also you can find out the given curve just divided by x cube, and what happens, this becomes 1 upon 2 by y by x, all those things. Now we can, as x tends to infinity, the c by x, whatever this y by x, y is equal to mx plus c, we know that as x tends to infinity, y is equal to mx plus c, and y by x is equal to m plus c by x. As x tends to infinity, c by x is going to become 0, and whatever these things, 1 by x, 1 upon x square, all those things become 0. By that we can putting the value here and also find out this quadratic. When we're going to get this equation, and after solving this equation we can get m value. Like this also we can solve it. This is how we can understand the things.